Hello everyone. So I'll be solving a easy lead code problem today. The lead code problem number is 242 valid anagram. So let's read the question. Given two string s and t, return true if t is an anagram of s and false otherwise. I hope everyone knows what an anagram is, but if you don't, then it also gives you a definition of anagram. An anagram is a word or a phrase formed by rearranging the letters of a different word or phrase, typically using all the original letter exactly once. So if you look in example 1, there are two strings s and t. So s is anagram and t is essentially anagram, but the words are rearranged or characters are rearranged within the given string. So if you look, both the occurrence of a is 3 over here and 3 over here, and simultaneously all the other alphabets like G, R, M, they are all one occurrences in both, and that's why it returns true. But if you look example 2, a rat and car are clearly not an anagram because there is no R in this string T and there is no C in string S. So you can clearly say that there is a missing character in both of them, and they are not an anagram. So this question, you can think of it in two ways. One of the way is directly you can sort these both the strings and then compare one by one that it should be exactly same. If there are anagram, then it would be exactly similar string after sorting. So this is one way of doing, and the another way of doing is using an ordered map, and I'll show you both. So let's start off with the easier one, the sorting approach. So, and one another observation I want to show you is, if if we say two strings are anagram, then that means the size of both the strings should be similar or equal. So in this case, anagram is 1 2 3 4 5 6 7, so seven character long. If it's an anagram, the other string would also be 7 character long. So you can easily write a if statement. If size of s and string is not equal, then you can directly return false, because there is no way that both the string would be anagram of each other if the size is not same. So we can say return false. Cool. And then we can directly just iterate over the both the sort. Oh no, I we need to sort the string first. So let's sort the string first, and then we will iterate over the both the strings to compare. So all right, so we have sorted both the string, sort on string S, and done the sorting on string T as well. So if you are aware about what time complexity is, so time complexity of both these sorting would be n log n, because I'm using a standard library sorting function. So the time complexity of standard library sorting is n log n. So that's the most efficient sorting algorithm. You can write your own as well, but since we already have a sorting function provided in C++ library, we will directly just use that. And now since we have sorted, we just need to iterate, and then we can just say uh, if both the strings are similar, then we can say it's an anagram, otherwise it's not. So let's do that. Also, you can just iterate over the, since we already are checking for the size, if both the size are not is not equal, we'll return false. So it doesn't really matter whatever the size is, because at this point the size of t and s should be same, and hence I just randomly just chose s over here. And then if we say if, so what this means is that the character at index I of string s, if it's not equals to the character at index I of string t, then we'll just say return false, because then it can't be an anagram because it's different. If not, if it has iterated, and if it comes over here, that means it's an anagram, because we haven't found a occurrence where both the characters are different. So let's try to run this. All right, so both the cases successfully passes. Let's try to submit it. All right, so it is accepted. So let's try the second approach. Let's to default. And now we'll be using unordered map. So in the concept of using unordered map is just get the element or get the character and just look for the occurrences of that particular alphabet. So anagram should have exactly same occurrences of the element. So element should be same and the occurrences of each element should be same. So that's the basic idea. Let's code it down. We will be having two maps, one for string s and one for string t. Oops. S map, ordered map. All right, so we'll just gonna iterate over. So I'm using a for loop. This is called a range for loop because I'm not exactly writing in a format where I'm using the iterator and define the iterator. You can directly use this range for loop to populate. So I'm just gonna do that. All right, so it will just take in that particular character and increases the occurrence of that character. So once we have populated both the maps, what we are going to do is, all right, so once we have these two maps, we are gonna do one more check, which is gonna be that size of both the maps should be same. So smap.size, if it's not equal, then we'll just say return false. If it is equal, then we'll just gonna uh, iterate over one of the map. So let's say, let's take s map. Now we are gonna check if it actually the element in s map actually exists in tmap or not. So tmap dot find. So we'll find that element. I first. If we do not find the key of smap, like that particular alphabet in tmap, then we'll just, that means that it's not an anagram. Or we also will be checking for the element, right? So tmap count, so its occurrence would be I dot first. If it's not equals to a dot second, which is the occurrence of this, or not a, it should be I dot second. Will return false. That means it's not an anagram. We check that either the element does not exist or the occurrence of that particular element does not match. Then we'll just return false. Otherwise, it should be return true. All right, let's run the test cases. Okay, test cases passes. Let's submit this. All right, perfect. It also got accepted. So there are two approaches I told you. One is using sorting, which is the easiest approach, but we'll be using in the previous approach I was using the sorting algorithm, which is already given by C++. So maybe that's too easy to solve it. The other approach is quite simple. Once you know how to use the unordered map, once you know how to get collect the occurrences of each alphabet, you'll just uh, iterate over the strings and populate both the maps. Once you have the map, just look for the size, and once you know the size, if the size is not same, that means we definitely it's not an anagram. If it is, then we just do the two checks. One is either the element exists or either the character exists in the other map, or if it doesn't, or if the occurrence doesn't match, then it'll return false, otherwise it should be returned true. So thanks a lot. I will see you in the next one.